Getting started here, right? Apache Kafka is an event streaming platform, right? So what does it mean is also we need to understand. Yesterday we understood what is event streaming, but today we need to understand what is event streaming platform and why that has been chosen the event streaming platform. We will understand one important concept is there that we will understand. So he explained in the document as well. Clearly he explained in the document. So to get hands-on experience with Kafka, go to this quick start guide, where in the quick start guide, so here how to extract the Kafka. So Mac users, please follow this link. Let me go to softwares and link. So Mac users, in order to download the Kafka and extract it, so please follow this. Mac users. So this is the link for Mac users. For Mac users. This is the link for the Mac users. Okay, please follow this link. The Mac users, please follow this. Okay, now here is the setup, how to do the setup and all is given. So clearly explained it, everything clearly explained. And see this, read through the brief introduction to learn how Kafka works at high level. So given introduction video and then, introduction documents, everything is given. Apart from this getting started guide, they also have given the document for us. So design, implementation, and APIs, key concepts. So getting started. So this is what the key concepts, introduction and use cases, quick start, ecosystem, right? And then upgrading from 3.4 to 3.3.x. So again, APIs, producer API, consumer API, streaming API, connect API, all these things they were given. Okay. And then if you can see configuration, broker configurations, design, implementation, lot of stuff has been given. Security, lot of stuff has been given. Okay, right. Now let's go to Wikipedia, Apache Kafka Wiki. Now click on this, go to Wikipedia. In Wikipedia, you can see Apache Kafka is a distributed event store and streaming platform, right? It is an open source system developed by the Apache Software Foundation, written in Java and then Scala. So if you can see the history, Kafka was originally developed at LinkedIn and was subsequently open sourced in early 2011. So these are the guys, Jay Krebs, Neha Narkade, and Jun Rao helped co-create Kafka. And later on time, what happened, this Kafka has been open sourced with the Apache Software Foundation. So initial release, January 2011, 12 years ago, the initial release was happened. And this is what the Kafka architecture will discuss in depth, each and everything. And then Kafka APIs will discuss about each and everything. But what is Apache Kafka? Apache Kafka is a distributed event store and stream processing platform. So that is what you can see here. Apache Kafka is an open source distributed event streaming platform used by thousands of companies for high performance data pipelines, streaming analytics, data integrations, and mission critical applications. Yesterday, we have seen one retail application, how critical it was, right? From the one POS machine, once a customer buy the products or grocery, an event will be generated. That event should have to be sent to multiple departments, right? That invoice should have to be sent to multiple departments. That is for only one customer. Assume there may be n number of customers in a single day. So n number of invoices have to send to n number of departments. So such a critical application it is, which will be solved using the Apache Kafka. However, we understood yesterday event stream. Now let us try to understand what is event streaming platform. Don't feel like I'm discussing only theory. No, this theory is foundation for further work what we're going to do practically. This theory is the foundation. Without this foundation, if you go and then try to do the exercises, you definitely will feel the difficulty and then again come back and then see here. So that is the reason foundation is very important. Please be patient. Let us try to understand each and every concept very clearly. Okay, what is event streaming platform? In event streaming platform, there is one or more producers or one or more consumers. So in event streaming platform, there were one or more producers and one or more consumers. Okay, so this is the architecture. Event streaming platform, meaning there will be one or more producers, there will be one or more consumers, and these producers and then the consumers will send the stream of events. Stream of events. In our earlier example, if you can see here, POS machines are the producers, and then the different departments are the consumers. These producers will produce the invoices to these consumers, right? So these are all now producers, these are all now consumers. Okay, so in the event streaming platform, there will be a producer, there will be a consumer, and there will be a streaming platform. Okay, so first of all, subscribe to a stream of records, and second, store stream of events, and third, analyze and process events as they occur. These three things will be happened in the event streaming platform. Let me repeat. Subscribe to a stream of records. Now we said this streaming platform, right? This is what the event storage. This is what we called as event storage. So you can see here in our slide. So Kafka is storing all the events, meaning invoices details as a JSON objects into one log file, right? So this is called what? Event store. So as the events produced by the producers are storing here, to get them by the consumers will connect to this storage, event storage. Similarly, to produce the events and to store the events in the event storage, these producers will connect to the event storage. So in typical, producers and then consumers will connect to the event storage and will exchange the events using this event storage platform. So these events are one or more continuously happening with a time gap. Hence, we call them as stream of events. As the stream of events are exchanging over the storage platform, then this platform is called as the event streaming platform. I believe it is clear for all of you. Okay, if any questions, you can ping in the chat as well. Fine. Now, in the event streaming platform, what we will have? We will have a storage. Storage contains what? Number of events as in the order how they are occurring, right? Maybe from the POS machine one occurring the events one after the other. One customer, once one customer completed his billing, then other customer will enter into the billing. So till that time, the customers will be in the billing queue, isn't it? But one POS machine, two customers billing is not happening at a time. That is not possible, right? So you go to one POS machine, I maybe stand behind you. Once you're done, then I have to enter here and then my payment will go here, isn't it? That means the invoices are happening one after the other are stored in the storage. So these invoices happening one after the other are called as events, stream of events. So stream of events are storing on the event storage. So this is called as event stream platform. So event stream platform contains what? The stream of events, right? Or the records. Stream of events or the records. So this is what the stream of records. Now, these stream of records, whatever were there here, right? So these stream of records were taken by the various consumers for their analysis and then process it. For example, shipment service will take the invoices and then delivers the products to the customer's doorstep. Finance department will take this invoices and then keeps the invoices in their audit books. And loyalty department will takes these invoices and then prepare the loyalty points for us based on the purchases we made. And based on those loyalty points, next time our bill get reduced by redeeming these loyalty points. So likewise, each and every operation, each and every department, each and every application is processing this event data, right? So that is the reason here we can see analyze and process events as they occur. Now, is it clear? Event streaming platform meaning the platform where the stream of events are going to be stored, and the stream of events which are stored in the event streaming platform will be analyzed and then processed by the consumers. Whereas these stream of events will be produced by the producers to store the events in the event streaming platform. Clear? I believe it is clear for all of you. Right. Okay. Kafka event storage and all, I'll explain where it will store and all, I'll explain. Just think about it now. Kafka will store the events. Where it will store, how it will store, we'll discuss once we practically do the things. Okay, fine. But now Kafka will store for a while, as the question asked. So where the Kafka is installed, so we can mention actually where this, okay, we can say on the machine, the events will be stored on the machine where the Kafka is running, and that machine only the events will be stored. Where those will be stored and all, we will see coming up content. Okay, so event streaming platform typically in a real platform like this. So Apache Kafka event streaming platform, this is the order service, and order service, inventory service, cart service, payment service, notification service, delivery service. These are all the services are using what this Apache Kafka event streaming platform to exchange the events, Events nothing but here the data object. We can consider same POS machine 1 to the loyalty department, POS machine 2 to the notification department, POS machine 3 to the order service department, something like that even we can consider. Okay, now differences between the traditional messaging system and then Kafka streaming platform. So what are the differences? Okay, in traditional messaging systems, transient message persistence will be there. That means if we take the traditional messaging systems like ActiveMQ, RabbitMQ, right? Or else any MQTT protocols, if we take, so the message is transient persistent, meaning the message once received by any consumer, let's say RabbitMQ is there. So RabbitMQ have the producers and then consumers, isn't it? So if any of the message once received by the consumer, then the message will be deleted from the queue. So this is called as what? Transient message persistence. But in the case of the Kafka will store that events for a period of 7 days by default. And these events are immutable. We can't change those events. If we try to change the event, or if we try to change the data, it will be one more event, isn't it? Okay. So traditional messaging systems like RabbitMQ, ActiveMQ will target a specific consumer. But Kafka streaming, any consumer can access a message from the broker. So you will get a complete picture on this once we've done the Kafka multi-node setup in Windows. And if we do a simple topic creation and all, if we do a simple exercise, you will get complete understanding on this traditional messaging system versus Kafka streaming platform. Okay, but mean that time, let us have these points in our mind. So traditional messaging systems are not distributed, whereas Kafka streaming system is distributed. This is very, very important point. People don't understand. I know if you study any books or if you study anything, you can't understand this ones. What is the meaning of it? So bookish knowledge or theoretically you may see, but practically you may not visualize this. Just bear with me for 30 more minutes. Probably I will showcase practically what is the meaning of this distributed. Okay, how Kafka is distributing the events. Fine. So this is the major difference between the traditional messaging system and then Kafka streaming platform. Now, Kafka use cases, if you can see, Kafka is using in the transportation business, like driver rider notifications and food delivery notifications, and retail also, like if any like brokerage.com or some house rent, some websites are there, right? If any property has been newly added for let out, then those sales notifications you will get. And real-time purchase and recommendations, what to be purchased, what are the recommendations, so those you will get. And tracking online order deliveries. So for these we can think of Kafka for sending the add-ons. For example, you can see the Google advertisements, right? When you open the YouTube, what you will see? You will see the advertisements over there, ads over there. So those ads also processed using the Kafka. I mean, those ads will be processed usually by the Kafka. So fraud transactions and a new feature are product notifications. The banking system also we can use the Kafka. So these are all the just use cases where we can use the Kafka. Not only this place, where the event need to be distributed, there the Kafka definitely required. We will discuss what is distributed and how it is distributing. Practically, I will showcase with one example. Okay. Till that moment, just go with this theoretical concept only. Okay, I do understand it is too difficult to remember these theoretical points, but practically when we see, you automatically came to know the meaning of these points. Okay, now the question is, why Kafka also using the messaging system? Why Kafka is also using the messaging system? Of course, we have the traditional messaging systems as well. Just now we have seen the traditional messaging systems have some problem, like they are not distributed. Kafka is distributed, right? But why the Kafka came up with that approach? Let us see. So Apache Kafka adapted a messaging system pattern to solve the real-time data integration problem. So as name suggests, a messaging system is all about sending small chunks of data from one system to another system. Messaging system is do what? It is delivering the messages from one system to another system. Okay. For our retail example, a single invoice could be considered as one message. In our POS example, that invoice can be considered as one message or one record, we can say. So when we talk about the message in this context, it could be a JSON record or something similar. So there are two approaches in the messaging. One is point-to-point Second one is pubs and subs. Now let us see the point-to-point. A point-to-point messaging system is built on the concept of messaging queues, senders, and receivers. P2P is built on queues, senders, and receivers. Each message is addressed to a specific queue. I think we can see this P2P architecture. Point-to-point communication. Just let me something like this, point-to-point communication. Point-to-point communication. So there is a point-to-point communication. Let me choose RabbitMQ. Right, now you can see here. Yeah, RabbitMQ official website. You can go and then see here. Right, so there is a publisher, there is a consumer. Publisher will publish the messages to the queue, and from the queue, the consumers will consume the message. Right, so what is happening here? There is a queue, there is a sender or publisher, there is a receiver or consumer. Okay, now each message is addressed to a specific queue. For example, this message is, let's say, shipment related message. It will go to shipment queue. Let's say this message is a payment related queue message. It will go to payment queue. The message that we need to send, reward points message we need to send, it will go to rewards queue, right? So each and every message will be addressed to a specific queue, and receiving clients extract the messages from their designated queues. So these queues retain all the messages into them until the messages are consumed or expired, right? So the queue will have the messages here until those will be consumed or until those will be expired here itself only. Okay, PTP messaging has following characters. One is each message has only one consumer. In point-to-point, single publisher, single consumer, single sender, single receiver. That is one characteristic. Second characteristic is sender and receiver are not dependent on each other. Sender is different, receiver is different. Sender and then receiver don't have the context, don't have the communication. They don't know each other. The only point is sender will send to some place, and then from there the receiver will receive. Okay, so it is something like, probably most of the cases, you will book one, maybe in Amazon you will book one t-shirt, right? So the t-shirt will comes to you through the Amazon. Amazon is the platform which is delivering. So you don't know the shop where the t-shirt was, meaning from where they are getting those t-shirts and then send, you don't know. But ultimately, the t-shirt, whatever you are requesting, you got it, right? So you don't know who is the publisher, and you are the consumer. You are just consuming using the Amazon platform. Same situations here, right? That is what P2P. So the receiver acknowledge the successful receipt of a message. Exactly. Once you receive the t-shirt, what you will do? You will send at the time of you are receiving the t-shirt by the Amazon delivery person, you will send one OTP to that person. That OTP will be entered in their system. That means it will give the acknowledgement back to the original manufacturers. How many, members were purchased, thus the t-shirt and all. So in the P2P, consumer will give the acknowledgement. Consumer will give the acknowledgement after successful recipient of your message. Consumer will give the acknowledgement directly to the publisher? No. Consumer will acknowledge into again queue, and from there the publisher will take it. Okay, so this is what the P2P point. So Apache Kafka rejected this one, P2P approach, because they want to address the many-to-many requirement. It is not one POS machine will always send the invoice to shipment service. No, one POS machine may send the invoices to different departments. That is the reason P2P was rejected by the Apache Kafka. Then let's go to pubs and subs model. So this is P2P, right? So let's go to pubs and subs model. So a publish or subscribe messaging system is built on the concept of publishers, broker, topic, and subscribers. So let us go and then see not point-to-point communication, publisher and subscriber. Publisher and subscriber communication model. Now you can see here. This is the official website of the RabbitMQ. You can see here. One client can send a message, different messages one client can send to, let me go and then get this. Let me go here. Yes, putting it all together, this is the one. So what is happening here in the pubs and subs model? There is a publisher. Any application that sends the data should act as a publisher. For our retail chain example, the POS application works as a publisher and it sends the invoice for the other applications. So people use different names such as data publisher, data producer, sender, whatever it is, right? So in the publish and then subscribe model, the sender is called as the publisher. Then the receiver is called as the subscriber. In our POS example, the various departments like shipment service, invoice service, so shipment service, analytics service, finance department, all these are called for the subscribers. Then similarly, there will be a broker. There will be a broker as well in this pubs and subs model. So we can go and then see more insights of it. Pubs and subs model. This is the AMQP model. Here you can see the queue. Yeah, you can just go and then see this. Yeah. There is a message sender. There is a message receiver. The single message may go to multiple receivers or multiple messages. A single message may go to multiple receivers via multiple brokers, right? So here, this is called as what? The queue, multiple queues you can see here. So in the pubs and subs model, there will be a publisher, there will be a consumer, and there will be a broker. There will be a broker. So that broker contains what? Again, the queues or topics, right? So the broker contains the queues or the topics. Usually in pubs and subs model, we can say them as the topics actually. So this broker contains what? The topic. For this topic, the consumers will subscribe, right? So now you understood P2P is single sender, single receiver. So there will be only one topic or one queue or one broker. Whereas in the pubs and subs model, there might be one or more brokers because we have the one or more receivers. Okay, so that is what the pubs and subs model. So Kafka is using this pubs and subs model. Kafka is using this pubs and subs model. Okay, so why the Kafka using the pubs and subs model now? Because Kafka wants to deliver the messages to many consumers. Okay, a one event can be delivered to many consumers. Hence, it is using the pubs and subs model, publishers and then the consumers model. Now, if we take the broker understanding, the broker is the heart of the pub-sub messaging system. Okay, so the broker is responsible for receiving the messages from the publisher. Let's say this is the publisher. Publisher will produce the message. Broker will receive the message and store them in a file or somewhere, then send that message to the subscriber. So broker is the heart of the pubs and subs messaging system. Okay, so in the pubs and subs messaging system, there is a publisher, there is a subscriber, there is a broker. One or more brokers also we may have. Okay, so the job of the broker is what? Broker is to receive the message from the producer and then send it to the consumers. And the broker will also store the message at the broker's node or broker's machine where the broker is executing. So the broker acts as a middleman between the publishers and their subscribers. We may have one or more brokers because it is the pubs and subs model. If there will be one or more brokers, if those one or more brokers are connected together, then that is called as a cluster. One or more brokers connected together, then that is called as what? Cluster. Hope you are following me, I believe. So the broker acts as a middleman between the publishers and subscribers. So Apache Kafka is a message broker here. Apache Kafka is a message broker. So we can create n number of message brokers in Kafka. So we usually call them as Kafka brokers. And it offers a set of APIs to implement the pubs and subs model. So producer API, consumer API, and then connect API, and then stream API. So complete Kafka architecture model you can see here. So this is what pubs and subs. And it will have the producer API, consumer API, stream API, connect API. So in our course, we will see this part. This part we will see producer API, stream API, consumer API. We don't discuss about this connect API. Okay, right. So Kafka is a message broker architecture. Kafka is following the pubs and subs messaging system. So when there is pubs and subs, there will be a sender or publisher, there will be a receiver, and there will be a broker. Similarly, Kafka also will have the senders, the receivers, and then the brokers. So if you can see our POS machines, these are all the senders, these are all the receivers, and this is the broker. We may have n number of brokers for the fault tolerance and then failover. Okay, hope it is clear, right? These brokers are queues? No. In Kafka, brokers are not queues, but in the ActiveMQ or RabbitMQ, the brokers are queues. Actually, RabbitMQ itself is called as a broker. The broker contains the queue. Broker contains the queue. And ActiveMQ is a broker. Broker contains the queues. Okay, queue and broker are not same. Queue, broker contains the queue. Okay, broker contains the queue. Got it? Now let's go and then see here. Producer API, streaming API, consumer API. These are all the Kafka APIs. So we're going to see producer, consumer, and then the streaming API. So part 1, we'll discuss about the producer, consumer APIs and understanding the Kafka cluster concepts. And in part 2, we will see the streaming API. Okay, so that's all right. Now let us go and then set up the Kafka in the Windows machine. So this is enough. Further, there is a lot of theory. Rather discussing this theory now, let me discuss this theory by doing the practical. Okay, so next, let's go and then install the Apache Kafka on Windows. So I have a detailed document on it. You can just refer this document, Apache Kafka. So go to this downloads and then click on this, and then we will be download, extract it. So I have a detailed document on it. So now let us discuss about the Kafka installation, and then we will understand the Kafka cluster. Okay. In order to install the Kafka in the Windows machine, what we need to do, go to this Kafka, click on download Kafka, and here click on this Kafka 2.12-3.4.0. So it is Kafka 3.4, but Scala 2.12. So Kafka is using the Scala. Kafka built on top of Scala. So Scala version is 2.12 and then Kafka version is 3.4.0. So when we click on this, you will see this Kafka 212 downloaded to your machine. Okay, so this is what downloaded. Copy this, go to any of your directory. So let me go to this Kafka UI directory, paste it here. Then right click on it and then extract it either using the WinRAR or either using the 7-zip. I'm using the 7-zip. Let me extract it here. Extract it. Now this tz tar zip, from the tar zip we got the tar. Now extract this tar again. Extract here. So when we extract the tar again, we got this tar. So this is what the Kafka. This is what the Kafka installer. Now if we Kafka distribution, if we can go to this bin, here we have the Windows version and this is the Linux flavor. So Mac guys, you just use this sh files and then the Windows users go to this Windows and here we have the various see Zookeeper and then Kafka producer you can see and then Kafka consumer you can see and then Kafka groups you can see and Kafka storage, Kafka server, Kafka topics, right? A lot of things are here related to the Kafka, isn't it? Now, yeah, you can see Kafka broker API versions, Kafka configurations, Kafka tokens. So all these things you can see here. Make sense? So this is what the Kafka binary. Now, as soon as you extract this binary, what you need to do is copy this extracted one to the C drive. Copy this extracted one to the C drive. So go to C drive and then extract it. So once it extracted, then what we have to do once extracted, open this and go to this. Here we have, right? Open this and then open the command prompt. Where you have to open the command prompt? Before the bin. Before the bin, we have to open the command prompt. So as soon as we open the command prompt, okay, first what we need to do is, first we need to start the Zookeeper. So why we need to start the Zookeeper first? For that, we need to understand the Kafka cluster. So Kafka brokers are often configured to form a Kafka cluster. A cluster is nothing but a group of brokers that work together to share the workload. So here in the system, one broker doesn't sufficient for us to distribute this much of load to the various systems. We may configure one or more Kafka brokers here. So those Kafka brokers, when we have configured, there will be a communication or understanding among all the brokers that we have configured here. So to monitor or to manage that communication, we required a software called Zookeeper. Zookeeper is the coordinator. Zookeeper is the coordinator of all these Kafka brokers. So a cluster is nothing but a group of brokers that work together to share the workload. And that's how Apache Kafka becomes a distributed and scalable system, because we are taking multiple brokers here and multiple brokers are managing by the orchestrator or coordinator called the Zookeeper. So it is similar. The name itself is saying, right? So Zookeeper job is what? In the zoo, he is coordinating or controlling. Basically, he's controlling the animals in the zoo, isn't it? So similarly here, zookeeper in the Kafka also controlling the brokers, coordinating with the brokers, managing the brokers, monitoring the brokers. So coordination is very important among these brokers while they are consuming the data or while they are producing the data. Meaning, while they are taking the data from the producer, let's say we have 1,000 records. First 500 records taken by this broker. And then the broker 2 should have to be know about the broker 1 have taken 500 records. It should have to take from 501 to 1,000. This also will take from 0 to 500. Then there is a redundant data. Correct? So that understanding, that coordination among these brokers should be required to have, and that is establishing using this zookeeper. So zookeeper is the coordinator or zookeeper is the orchestrator. So that we need to first set up. So let me go and then draw something here. So what is this orchestrator meaning? Orchestrator meaning is a person, central brain. So let's say zookeeper. Zookeeper is an orchestrator or a person or a central brain who is managing all the brokers. So here is the zookeeper. And this zookeeper is managing what? All the brokers. Let's say this is broker 1. Maybe we can say this is Kafka broker 1. And maybe this is the Kafka broker 2. And let's say this might be the broker 2. And yes, broker 2. And similarly, we have the broker 3, broker 4 and all. So this zookeeper, these brokers are all connected with this zookeeper. These brokers will be connected with this zookeeper. Now zookeeper will coordinate these brokers. If any of the broker is down, then zookeeper immediately make one of these brokers as a leader. So remember again, if there are a group of brokers, one should be elected as a leader. One should be elected as a leader or master, isn't it? So usually we are of the team members, right? For example, you have a team of 10 developers. Among those 10 developers, one should be elected as a master to better manage one should be elected as a leader or team lead to manage the team. And still the team lead is there will be again manager as well. So that manager is nothing but the zookeeper. So this manager will remove a person from the team or add a person to the team, right? And this manager will coordinate with all the teammates. Among all these teammates, one person is act as a team lead. Assume if the team lead is on leave, then this manager will make another person immediately as the team lead for that 2 or 3 days, and he will be the team leader. And when the team lead will be back from the vacation, and he will be take his responsibilities. So exactly the same situation here as well. Zookeeper is like manager. Brokers are like teammates. One of the brokers should be elected as a master to manage these brokers. And what is the job of the zookeeper? Zookeeper job is to maintain the brokers in the cluster. Cluster meaning a group of brokers connected together. A group of brokers connected together with the orchestrator. In always, remember, in always cluster, there will be an orchestrator. Okay, I believe you got these points now. So let's go and then start the zookeeper first. So go here, and before starting the zookeeper, here we can see one more thing. There is a config directory where we can see the zookeeper.properties file. Just I'm opening this. zookeeper.properties file. Let me close all others. Close all but this. No to all. Okay, so this is the zookeeper. So see, the data directory for the zookeeper is what? Temp directory. And client port, the port at which the clients will connect. Here the client meaning brokers. Brokers will connect. Apache Kafka brokers will connect to this zookeeper, right? As mentioned here, Kafka brokers will connect to this zookeeper on the port 2181. Then admin enable server is false. Disable the admin server by default to avoid port conflicts. Set the port something non-conflict and choose to enable this one. So server port, let's say admin server port is 8080. We can give some other port and then enable the admin server, but not required this admin server. Zookeeper admin server console is not required, even though if we open, I don't think it is working as expected. I tried it. So forget about this property and just concentrate on this one. So when the zookeeper is starting, the zookeeper is maintaining the data of it inside the temp directory. So with this configuration file, we have to start the zookeeper. Where are we? Where we open this CMD? We open the CMD at this one, Kafka. Now what we need to do? /bin/windows. Here we can see zookeeper server start.bat. And similarly, /config and zookeeper.properties. Now the zookeeper will start. So once the zookeeper is started, right? So once the zookeeper is started, then the brokers are trying to connect to the zookeeper. So for example, go to this C and then type here .temp. You can see the temp directory. See this? Zookeeper is created. Version 2, snapshot 0. Nothing is here at this moment, but zookeeper directory is this one. Okay. Now, let us set up single node cluster. Single node cluster in the sense, one zookeeper, one broker. Meaning one broker, one sender, one receiver. Okay, so go here, open the command prompt one more time, and then here, go to bin, go to Windows. Here, let us start Kafka, one moment, guys. Let me refer the document. Just give me a minute. Don't worry about the theory, whatever you can see in the document. I'll explain that theory, everything I'll explain. Okay. Now let us start this Kafka server. Kafka server, broker, let us start. So Kafka server. Okay, Kafka server, let us start. Now Kafka server, when we start, it requires the one property file. That is this one. Config server.properties file, which contains the broker number 1 or broker ID 0, and then port number 9092, and then the other properties we'll discuss log directory, right? And then the partitions, other things we'll discuss going forward. But this is what the server. So now we are starting the server. That means broker. So this is the broker we are now starting. Broker 1 we are starting. Broker 2, something like that. So in the single node cluster, now we are going to set up, now we are setting up only the single node. So in single node cluster, we'll have only one broker. Now let us set up this broker. So how to set up the broker? Run .config server.properties. Now the broker is going to be set up and then broker connected to the cluster, meaning this broker is now started and then broker connected to this zookeeper. So how I'm saying the broker connected to zookeeper? Somewhere we can see the log and then we can say that is connected to Zookeeper on the port number 2011, isn't it? So see this ZK broker, right? Zookeeper broker. And we can also see carefully the log, and we can see it is connecting to the Zookeeper. So these are all the broker properties by default. These are all the broker properties by default. So a lot of properties by default it is configuring, right? Based on our need, if you want, we can change it. Okay, so here in this properties, we also can see the Zookeeper port number and where the Zookeeper is. Okay, so message that properties broker ID is 0, and then broker session timeout is 9,000 seconds. And here you can see somewhere the Zookeeper port number as well, Zookeeper related port number and all. And you can see the logs as well, right? So broker's IDs is 0. And this is what the start of the created Z node, Zookeeper node. And you can see here, finally, we can see ZK broker has been created, right? And then these are by default will refer to the Zookeeper on the port, Zookeeper port. Okay, fine. It is now connected, meaning the broker is now connected. Next to what? We need to have one sender. So this is the sender. Here we need to have one sender, and we need to have one receiver or one consumer, right? So here is one producer and here is one consumer. Okay. So producer will sense the data which will be stored in this broker, and then the broker will again send it back to the consumer. Multiple broker is the next concept, Samrat. I'm talking about the single broker. You are asking the question on the multiple brokers. How it relates to this topic? Again, what I'm saying is, if you can see the course agenda, in the course agenda, I clearly mentioned single node broker, multi-node broker. So we're going to configure it multi-broker as well. Okay, now we are discussing the single node broker. Concentrate on the single node broker. Make sense? Right. Yeah. I didn't get your question. Even for one broker also we need Zookeeper. Yes, Zookeeper is required. Zookeeper is required even for one broker as well. Because Zookeeper is what orchestrator. Let us say you got a project. You are only one developer. Don't you require a project manager? Yes, required. In case of you are absconding, who is the responsibility of taking care about that project? Right? Zookeeper only. So meaning the same scenario is replicated for managing one broker, even that is one broker or multiple brokers, managing the Zookeeper is required. So from 2.8, it is different story. I'll come to that point later on time. Okay, right. So on one Windows machine, remember carefully, this is my Windows machine. On Windows machine, on my Windows machine, we can create one broker or many brokers, single broker or multiple brokers we can create on my Windows machine. Okay, that is what I'm talking about, Samrat. That is what I'm talking about clearly. Please follow me. Actually, maybe you guys join the session or listening somewhere, again come back and then ask me the repeated questions. Listen to the session carefully and then ask the questions. That is what I'm saying. On the same Windows machine, okay, multiple broker configurations is possible. That is what multi-node configuration we will do. We will do it. First, understand this one. Okay, so there is a producer, there is a consumer is now required. So, but producer, this broker is there na? Broker required what? Event. Broker required what? Event. If you can see the broker, we have started using this server dot property file, isn't it? So broker, we started using the server dot property file. So broker have this directory, temp slash Kafka logs. Now let's go and then see the directory. So go to C location and here type temp. Now you can see the Kafka logs. This is what the broker one, or we are talking about only single node broker. So single broker data directory is this one, Kafka logs. Okay. So now carefully observe, this is very, very important point. So Kafka, this single broker have its storage in the temp directory. So this is what its storage. Let me keep this storage here. So this is the storage. Okay. But now broker receives the data from the producer and broker will send the data to the consumer via topic. So we have to now create one topic. So this is that topic. So using the topic, the broker will receive the data and then broker will send the data to the consumer. So now we need to create one topic. So broker will do what? Use this topic and producer will send the data to this topic. So broker will store this topic here and the topic contains the events and consumers when requesting the message from the broker, then broker will go to topic and then give it. So what we understood, we require a topic now. So what is topic? What is topic? So the topic is the mechanism to categorize the messages. If we are coming from the database world, we can think of topic as a table. Topic as a table name. Here in the Kafka, topic is just a name, just a file. Okay. So the producer always writes the messages to topic and the consumer reads it from the topic. The broker creates a log file for each topic. So topic is just a name. For that name, the broker will create a file with the same name of the topic. Topic is just a name. So with the name, the broker will create the file, log file in the broker log directory. So when a producer sends a message, it specifies the topic name for the message and accordingly, the broker parses the message in the corresponding log file. So when consumer wants to read this message, they consume message from the specified topic. Okay, so send to topic and consumer will take the message from the topic. So what did you understand now? We need to create a topic. Okay, so create a topic. So how we can create a topic? We can create a topic. Okay, to create a topic, go here, go to bin, go to Windows. Here, let me open one more command prompt. So now we have one command prompt for Zookeeper and one more command prompt for the broker. Now, again, I opened one more command prompt here for creating the topic. So how to create the topics? Kafka-topics.bat file is there. Here, we have to give the bootstrap server, the broker, one broker. Among all the brokers, one is elected as a master, right? Team leader, right? So one broker host and then the port we have to give. And then in that broker, we have to create a topic. And then that topic we will divide into partitions and replication factor. Again, about these two, let us discuss later on time. So first, let us go and then create the topic. Okay, so topic is created. So topic created meaning go to again our series broker. This is our broker directory, right? Now what happened? Topic is created. Test topic is created. Can you see? So what we done actually? We have now given Kafka topics.bat hyphen bootstrap server. Give the broker, one of the broker, master broker, and then create a topic, topic name. About these partitions, I'll discuss later. But now the topic is created. Okay, topic is now created. Yes, topic can be created using Java. Yes. Now the topic is created. Okay, then next what? Producer. Now if you can see here, topic is created here. Topic is created. And then the same topic you can see here as well, isn't it? The same topic we can see here as well. So let me go and then just change this, paste here. Now see, topic is created. Now topic is there, broker created a topic. Now the producer can send a message to this topic, isn't it? So now what we will do, let us send the message. So I have a data file. So we can list out the topics that are created. We can describe a topic. So whatever the topic we created, right? So we can list out all the topics that are created from the brokers. So we have the test topic, and we can even describe it. So how we can describe? So just give hyphen describe, hyphen describe. So Kafka topics is the utility we are using now. And bootstrap server, nothing but one of the master broker, and then describing it. You can see topic name, topic ID, partition count, replication factor. So we'll discuss about all these things later in time, partition count and then replication factor. Okay, now let us send a message. Okay, so let us send a message. So in order to send the message can be sent by whom? The Kafka producer. So let me have one file, one data file. Let me have one data file. Go here, go to here, Apache Kafka data. Let me have this sample file. So the sample CSV file, let me have in the, probably in the config. Or else let me have it here. So now what I will do is, topic is created, right? Now what I will do is, let us send the message by the sender. So Kafka console producer.bat we will use. And then broker list, master broker or single broker, whatever we have now. And then the topic, then give the location of the file. So let's give the location of the file like // Now side docs we got. One moment, we have to give the location of it. Okay, where we came, side docs. Yes, so we came here. Here sample1.csv, isn't it? We have. Okay. Come to one more. No. So here itself only bin config libs licenses notice side docs bin. Okay. So it is not identifying this file here. Let me keep it inside this config. Okay, now go here. What I want, config slash sample 1.csv. This is the file, isn't it? Okay, let us now send it. The system cannot find the path specified. Okay, so let me keep this sample file. Sorry, I have to keep this sample file where? In the C drive, right?
This is in D drive.
Yes, I have to keep it in the C drive because we are referring from the C drive. My bad. So go to this Kafka 2.1.3. Let us keep it here. Now go to here, producer, one step back. Then let us see, one step back. Yes, sample1.csv. Perfect. Now what happened? We have sent the data. We have sent the data. Send the data to where? To the topic. Now go to topic. Go to topic. Here you can see one log file is created, right? With the 1024 kilobytes of the data. And one partition is created, right? Okay. Then sender sends the data. That means sender, producer, send a message to this topic. Now consumer, let's consume the message by the consumer. So here is it. So from the beginning, let him consume. Okay. So consumer, see this Kafka console consumer, Kafka console producer we are using. Now consumer is now consuming the data. Let us see. Yep. Excellent, right? So consumer consumed the data, whatever we sent, right? Total, how many records we have? Those many it consumed. See, it processed a total of 1907 messages. So here in this file, we have the 1907 messages. 1907 records. So these records now consumed by whom? By the consumer. So producer produced the data to the topic, and from the topic, consumer consumed it. Right? So there is one broker now, one producer, and one consumer. We can have many consumers as well. We can create many consumers as well. So that part we will see in the next session. But now you can see broker created a topic, and using the topic, the data is being exchanging or sending between the producer and then consumer. Okay, that's all for the today's week, guys. And next week, let us connect and then see the multi-node cluster setup on Windows. Again, we will set up the multi-node cluster on the AWS as well. Then we will continue understanding the furthermore concepts. We just now understand the topic, concept of topic. But whenever you see the topic, right? So this topic have the partition. So what is this partition? The job of the partition, we have to understand. Now this is the indexed file. So this indexed file also we can read. So how to read this indexed file and all, we will see later in time. If we open this one, probably this indexed file, see, we can't read the data, right? But there is one utility to read the data. We'll see that in the next week. That's all, guys, from my side.
Sir, one question, sir.
Yes.
We have Zookeeper, those things you have given just overview, and how it will manage, and those things we will be discussed in further topics or what?
Which one? Zookeeper?
Zookeeper, yes, sir.
Correct. When we discuss about the multi-node cluster or multi-broker cluster, again, we will discuss about this Zookeeper.
Okay. So in the command line, you passed port number, sir, right? So
Hmm.
that is the default port number for the, I mean, for producing, like, that is the port
Ha,
number for the,
correct. So you can see zookeeper.properties. The clients can connect with the zookeeper over the 2181. And then server, meaning the broker. Broker port number is by default 9200, sorry, 9092. This will take by default. So when we go to multi-broker, then we will enable this property and will give different port numbers.
okay, got it.
That we will see next week.
So can you open once consumer and producer, like command you pass, right? Port number 9090, right, sir?
Correct. So let me open this. Okay, this is what, one moment. Server. This is what the zookeeper. So this is what it is. Let me now see the command. Yeah, Kafka console producer. We have passed broker and then its port number. And similarly, so here if you can see, the producer need to send the data to this topic, right? Of the broker, this one. Again, consumer also need to get the data from this topic and from this broker. So we have given for the consumer as well, we have given this broker one. See, broker.
Okay, sir. And one thing, sir, later we will discuss, right, sir, how this one we need to take the consumer like that, how it will know, like
Correct, correct.
further we will discuss, right, sir?
Further we'll discuss. The
Okay.
first concentration is understanding the Kafka core APIs. Like what is topic, what is partition, what is index, what is replication factor, what is replication, what is offset. So these are all the things we have to discuss completely, understand completely. Then once the core API understanding is we got, then we can go and then implement it on the applications, any of the applications, Spring Boot, whatever the application, you can implement it. Fine? Right. Okay,
And
someone asked, petabytes of the data can be handled by the topic. One topic can't handle the petabyte data. It is not possible. Rather than one topic, we will take more than one broker. Each and every broker can have one topic. So multiple broker with the multiple topics can handle the petabyte of data, but one topic can't handle. Okay.
the routing, sir, when it is a petabyte, again, Zookeeper will have that intelligence to route to this topic because already this topic is handling this much memory of information.
Correct. So the management is doing by the zookeeper. We will see how when the multiple broker concept came, how the routing will be happened and all. We will discuss. There is a indexed based routing will be happened. So
Okay.
offset, there is a concept of offsets. So here you can see test topic 0. We have given name as test topic only, but here we have test topic 0. What is this 0? It is an offset. What is offset? How the offset will be maintained? First, we will understand the core concepts. Then we will see the advanced concepts, like how you said, how the routing will be happened, when there will be a multiple brokers, multiple topics, isn't it? So in the next sessions, we will discuss all those things.
And second thing, sir, logs, no, I see so many logs. So is there any filter mechanism?
These are all server startup logs, actually. So these logs are startup logs. Of course, these are all info logs. If we don't want, we can take the next level, like only warn we want, then set the log level. We don't get all these logs. But these are all the startup logs. When the zookeeper starting up and all, these are the startup logs. And when the broker started, lot of startup logs we got.
Okay.
So info logs they are actually if we block info, we will miss the information as well. Like see how it is generating the logs and all. So one thing we can do, we can have the different loggers mechanism here. For console, only have warn. For file, enable the info level. Likewise, the medium of the store where the logs are storing, the log level we can enable and then manage the logs. Got it?
Okay. And last one, sir, regarding this messages, when publisher is publishing to topic, okay, now topic has that for 7 days, correct? Default.
Correct.
So is there any mechanism of encrypting this?
Yeah, already encrypted. You can see the data in the Kafka topic. Data is encrypted. See, we are not able to see. Are we able to see? No. Data is already encrypted. Got it now? Inside the storage, data is encrypted.
But
We
it's
are
a
not able to
default,
see.
correct, which has not been certified. So if we want to have our own encryption, like for the Oracle tables, we'll encrypt the data, correct, before storing into the tables. The same way here, we can use the same ingress here also to encrypt the data.
Actually, that I'm not sure because no one will do that. Everyone will go with the topic encryption only.
No, they can
Because
do that. If you want to encrypt, you can encrypt and send up a topic. That's it.
probably we can, but I didn't use that actually. So
Because
whatever
at
the
the end of the
topics,
day, it is a log file, correct? The events are
correct.
in log. So compliance issues will be there. That's the reason. Just I'm curious.
Yeah, obviously. So this is a log file. If it is a usual ASCII text log file, yes, there is a problem. But this is not ASCII text log file. This is an indexed file. And this is purely encrypted file. So if it is a plain text, yes, there will be a problem. We need to just think about it. This is text document. This is a plain text. But this is not plain text. It is an indexed file. So there is a lot of meaning for the indexed file. So that is what we're going to discuss. You can see in one of the document, we're going to discuss that in future lessons. This is what that indexed file. So there is a meaning for it, how it is indexing and all. So once topics are going on, probably your questions will be resolved. Yes, I think we don't need to worry about that data encryption and all. One point may be valid because this is the default encryption. If anyone is master in the Kafka, maybe they can decrypt and they can see, right? Yes, possible. Even if you want, we can also have our own encryptions as well. But I'm not sure how to configure them on this Kafka topic. Okay, got it, right? At least I have not worked on that.